Hello, my dear students. How are you all? I hope you all are doing good. So my name is Aditya Jain from askIITians, and we are going to start a topic of your grade 8, which is known by some natural phenomenon. Okay. So before starting the topic, do you know what is cyclones? If I talk about cyclones, we all have studied in class 7th about cyclones. That cyclones are, I can say, a fast moving wind. Fast moving wind is known by cyclones. Okay, so cyclone does what? Cyclone produces a lot of loss to life and property. Yeah, cyclone gives a very huge loss to life and property. Okay, and also one thing about cyclone is that we can also prevent ourselves from cyclone by taking some necessary precautions. Okay, so cyclones is something which is known as natural phenomenon. Yeah, this is a natural phenomenon of the nature which you can't do anything with. Yeah, this is not in our control. This is not in human control. Okay, so basically we are going to discuss some natural phenomenon in this chapter. So before going into the main topic of natural phenomenon, let's see something about daily life activity. If I give you example that in our childhood, what we did, we used to rub the hair, or we used to rub the comb with our hairs. Yeah, we used to rub the comb with our hairs, and then we take that comb near to the pieces of paper. Yeah, then we take that comb near to the pieces of paper. Then what you observe that pieces of paper are getting attracted by the comb. That pieces of paper are getting attracted by the comb. So that is something associated with charges. That is something associated with charges. So in today's lecture, what we are going to study, we are going to study something about charges. That what are charges? What are their some properties? Okay, so basically we are going to start this topic of natural phenomena with the name given by charge. Okay, so now quickly move on to the main topic of today's lecture. Okay. Yes, this is the natural phenomena. Okay, this is what we are seeing is lightning or thunder. Yeah, thunder in the sky, lightning, thunder, that we'll see in the next lecture. Okay, so today what we are going to discuss, we are having some introduction. We have already started with some introduction. Now what we are doing, we are going to do today charge is any property. What is charge? What is its properties? And we will going to study about methods of charging, how to produce charging in a body, and then we'll see something known as electroscope. So today we are going to cover these main topics. Okay, so if I define charge, so charge is basically a fundamental property. You can say fundamental or inherent property of any body. Fundamental or inherent property of any body. What does it mean? Because supposing I am holding this pen, yeah, suppose I'm taking this pen, this laptop, this watch, this table, you, me, all are made up of charges. All of us, or I can say all the universe is made up of matter, and matter is made up of charges ultimately. So charges are present everywhere. Charges are present everywhere. That's why I said that charge is a fundamental or inherent property of any body that is present on it naturally. Okay, so everybody in this universe has some charge. Okay, so that is the charge. Basically, we know there are two types of charges. We already studied. One is positive and another one is negative. So there are two types of charges, positive charges and negative charges. This is the basic thing about charges, that they are fundamental or inherent property in any body or on any body. These can be of two types, positive and negative. And there is something known as neutral also. If you have heard, there is something known as neutral. Neutral means total positive charge on any body is equals to total negative charge. Okay, suppose I am saying there are +5 charge on any body and there is -5 charge on any body. So if we calculate total charge, it will be +5 -5, that will be 0. So that is known as neutral. When total positive charge is equals to total negative charge, that condition is known as neutral condition, and that body will be known as neutral body. So if you can see, I added the charges. I added the charges algebraically or with the sign. So this property of charges is known as additivity of charge. Additivity of charge. Then you can algebraically add charges on any body. What is algebraic? Means sum with sign. Suppose I am saying +3, +5, -6, plus 7. These are the charges present. So how to add them? We will directly add them. Plus 3, plus 5, minus 6, plus 7 with sign. That is known as algebraic sum. So this will give you 3 plus 5, 8, plus 7, 15, minus 6, 9. So the charge will be 9. So are you seeing this is a kind of, I can say, incomplete data. This is kind of incomplete data because there is something missing from this. There is something missing from this. What is this missing? Unit. What is missing? This is the magnitude of charge. Unit is missing. So unit of charge is Coulomb. Unit of charge is given by Coulomb. Coulomb is the name of the scientist. So in the honor of the scientist, the unit is given name as Coulomb, which is represented by capital C. So the complete answer will be 9 Coulomb. Okay. So this is the basic introduction about charges. That charge is the fundamental or inherent property in any body. It can be positive and negative. Neutral is a condition in which total positive charge on any body is equals to total negative charge. Okay. And what is the unit of to measure charge? The unit to measure charge is coulombs, and charge as a property which is known as additivity of charges. Charge as a property which is known as additivity of charges. Okay. So additivity of charges means you have to add all the charges with the sign, or I can say algebraic sum. So this thing is clear. So basic started we have done with the charges. Now we are going to see the important 2 properties mainly, or 3 properties mainly. Yeah. So first property is this, as we all are aware about this. Yeah. As we all are aware of this. So you can see in this diagram, if a person is placing 2 charges, this central charge is already positive. This is stationary, or this is fixed with a rod. Yeah. So this charge, central charge, is fixed with the help of a rod. Now we are placing 2 charges, positive and negative. So what you are seeing, positive is moving away from this central positive charge, and this yellow negative charge is moving towards the central positive charge. So can I say this positive charge, central positive charge, is repelling this positive charge? Yes or no? That's why it is moving away from it. Yeah, this is kind of repelling it. And what this negative charge is doing? Negative charge is getting attracted toward the positive central charge. Negative charge is getting attracted towards this central positive charge. So we will say this attraction. We will say this as a attraction. So can I say the property will go like this? The same charges, like means same charges, like means positive, positive, or you can say negative, negative. So 2 like charges, that is positive, positive, or either negative, negative, they will repel each other. They will kind of repel each other. And opposite charges like positive and negative. Opposite charges means positive and negative. So they both will attract each other. So that is the first and foremost important property of charges, that like charges repel each other and unlike charges attract each other. That is the important property. Like charges mean either 2 charges can be positive, positive, or they can be negative, negative. In both the cases, there will be repulsion between the charges because they are like charges. What about unlike charges? It means positive and negative. So if one positive charge is present near another positive charge or vice versa, then both will attract each other. So that is the first property of charge. I hope it is clear. Yeah, thumbs up. Okay. So now moving on to the second property, which is known as quantization of charge. Which is known as quantization. Quantization is made up of basically one word, quanta. Quanta. Quanta basically means packets. Quanta means packets. And packets is something like complete. Yeah. We can't say this is half packet. Yeah. Packet is already full. So what I'm trying to say, quantization of charge is this. Suppose there is 2 body, A and body B. Okay. There is body A and body B. Before going into this property, let's discuss one important property also, that the fundamental unit of charge. The fundamental unit of charge is the charge on 1 electron. Charge on 1 electron. So have you heard about electron? Negatively charged particle. So the basic fundamental or unit, or I can say the smallest unit of charge possible. The smallest unit of charge possible is the charge on 1 electron, and it is represented by E. It is represented by E. So E is the charge on 1 electron, whose value is given by 1.6 into 10 to the power minus 19 Coulomb. So this is how much charge is present on a single electron. And this is the minimum possible value of a charge on any body. This is minimum possible value of charge on any body. That's why it is known as fundamental unit of charge. That's why it is known as fundamental unit of charge. Am I clear? So the minimum possible value of charge on any body is charge of 1 electron, that is E, and that is equal to 1.6 into 10 to the power minus 19 coulombs. That thing is clear. Now coming back to this property, quantization of charge. So we have already discussed quantization means quanta, and quanta means packets. Quanta means packets. Is this thing clear? Quanta means packets. Okay. So what this property says, suppose this body is having a charge of 10 electrons. Yeah. And that is having a charge of minus 10 electrons. This is having a negative charge. This is having a positive charge. Okay. So what can I say if I want to transfer the charges between two bodies? Can I say, in the first case, I am saying I am taking 1 electron from this side to this side. In the second case, I am saying I am taking 2.5 electrons, means minus 2.5 E, because charge on 1 electron is E, and that is negative, means minus E. Minus means negative charge. So that is minus 1.6 into 10 to the power minus 19 coulomb. So I am saying minus 2.5. So what this minus 2.5 says, it says 2 complete electrons. Yeah, 2 complete electrons and 1/2 electron. That will make 1 plus 1 plus half, that is 0.5, which will be equal to 2.5. So this is not possible basically. This is not possible because charge cannot be, I can say the charge of electron cannot be break. Cannot be break. It is indivisible. It is indivisible. Indivisible. So 2.5 means 1 plus 1 plus 0.5. So you cannot break a charge. You cannot break a charge. That is known as quantization of charge. Quantization of charge says charge is quantized. Charge is quantized, or I can say charge always exists on a body in whole numbers. It is not like that you will take a 2 complete electrons and 1/2 electrons by breaking it into 2 parts. No, either you can take 1, 2, 3, 4 and so on. Yeah, either you can take 1, 2, 3, 4 and so on. So that is known as quantization of charge. That charge on any body is always quantized. So what does quantization of charge says? Charge on any body is quantized, and quantized means always in terms of E. Either it can be charge of 1 electron, 2 electron, 3 electron, 4 electrons, or 0. Yeah, either it can be 1 or plus minus, both sides, plus minus, plus minus, plus minus. So that's why quantization of charge means Q is equals to NE. What does that mean? That charge on any body Q is always an integral multiple of charge of an electron. What do you mean by integral multiple? Means in whole numbers. Either it can be 1, 2, minus 1, minus 2, 0, plus 1, plus 2, and so on. Either it can take up to 1 crore value. Yeah, it can be 1 million electron charge. It can be 1 million electron charge. Yeah, but yeah, the thing is that charge should be always in whole numbers. It cannot be broken. So the quantization of charge means charge on any body is an integral multiple. Is an integral multiple. Integral means N. Integral multiple of E. That means charge of an electron. So what does quantization of charge say? As you can see here, Q is equals to NE. Q is equals to NE. That charge on any body is an always integral multiple of charge of an electron. That thing is clear? Yeah, that thing is clear? Okay. Now see this second, which is known as conservation of charge. So what do you mean by conservation of charge? Conservation of charge means charge is always conserved. What can I say? Charge is always conserved on any system, or I can say isolated system. So this law is defined for isolated system. What do you mean by isolated system? Isolated system means you are not creating any disturbance from outside the system. Yeah, you are not creating any disturbance from outside the system. That will be known as isolated system. So what does conservation of charge says? That for any isolated system, the total charge is always conserved. The total charge is always conserved. Getting my point? So if I give you an example of this, what can I say? Suppose this is a system in which 3 bodies are present, A, B, and C. Suppose this A was having a charge of plus 1E, this B was having a charge of plus 3E, and this C is having a charge of minus 5E. This was before initial condition. Now I have redistributed the charges between all the three bodies, and after redistribution, now the charge on three body looks like this. The charge on A is plus 5e, charge on B is minus 3e. Then what should be the charge on C? So you see, this is an isolated system. It has no disturbance from outside. Whatever redistribution I have done, that is from inside within the bodies. This is a system. So this is inside the system. What we are doing as rearrangement. So if you see what is the total charge in the system, add charges algebraically. Plus 1, plus 3, minus 5. This will give you 1 plus 4 minus 5 minus 1. So this minus 1v is the total charge before redistribution. And what is the total charge after redistribution? Let's say the charge on body C is Q. So can I say the total charge will be 5e minus 3e plus Q? That will give you 5 minus 3, 2e plus Q. So this is the total charge after redistribution. And what does conservation of charge says? That charge on any isolated system is always conserved. Conserve means total initial charge will be equals to total final charge, because charge can neither be created nor be destroyed. It can only be transferred from one body to another body. That is the thing. So that this will be minus 1e will be equals to final charge 2e plus Q. This will give you Q is equals to minus 1e minus 2e. That will give you minus 3e. So we have find what will be the charge on body C with the principle of conservation of charge. Yeah, we have find all the charge present on the body C with the help of conservation of charge. So that thing is clear, that charge on any isolated system is always conserved. So I hope this conservation of charge is clear. This conservation of charge is also clear. Done? Okay. So we have done some basic properties. Yeah, that first charge is additive in nature, additivity of charges. That then we move on to like charges repel, unlike charges attract. Then we see quantization of charge. That means charge is always an integral multiple of charge of an electron. Conservation of charge means for any isolated system, the total charge is always conserved. Am I clear? Okay. Now we are observing various methods of charging. That what are the various methods of charging available to us? Yeah. So first method, or the common method, is known as friction, or you can say rubbing. Friction, or you can say rubbing. So what happens actually in rubbing? There are two bodies. Yeah, there are two bodies. Suppose this is body A and this is body B. So what happens? Actually, they are neutral. They are neutral at initial position. Neutral doesn't mean it doesn't have any charges. Neutral means that the total positive charge are equal to total negative charge inside the bodies. That is meaning by neutral condition. That doesn't mean that they have no charges. The condition is that the total positive charge inside the neutral body is equal to the total negative charge. That is the thing. So what happens in friction or rubbing? You rub two bodies like this. You rub two bodies like this. If I give you an example, when you rub these bodies, when you rub your palms, yeah, regularly rub your palms, what will you observe? You will feel some warmth. You will feel that your palms are getting warm. So there is some transfer of energy. Yeah? There is some transfer of energy that is due to the transfer of charges. That is due to the transfer of charges. Okay. So what happens basically, this is neutral, this is neutral. If you rub both these bodies, there is some transfer of charges takes place. And always remember one thing in mind that is very, very, very important, that in charges only electrons will flow. Only electrons will flow. That means only negative charge flow. Only negative charge flow. There is no flow of positive charge. There is always flow of negative charge, or you can say electrons during any charging method. Yeah. So one thing you should remember, or this is very important, that during any charging method, there is only transfer of electrons, no transfer of positive charge. Okay. Negative charge means there is excess of electrons, and positive charge means there is deficiency of electrons in any body. Suppose, for example, I'm saying this is body A, this is body B. Body A has 10 electrons. Yeah. And it has, I can say 12 protons. So what do you mean by protons? Protons are just opposite to electrons. The difference is only that they have charge plus E and electrons have a charge minus E. And you know E is 1.6 into 10 to the power minus 19. So protons are positively charged particles and electrons are negatively charged particles. Suppose I am saying it is having a 10 electron, that means minus 10 E charge, and 12 protons, that is plus 12 E charge, because each proton has a charge E and each electron has a charge minus E. So what is the total charge? Total charge will be 12E minus 10E, that will be 2E. So that, can I say the body has a total positive charge on it plus 2E? So what can you conclude? If any body is having a positive charge, that means it has more number of protons. Yeah, it has more number of protons than electrons, or you can say there is deficiency of electrons. There is deficiency of electrons. Yes or no? And what about this body V? Suppose I am saying this body has 12 electrons. That means minus 12 E charge and 10 protons. That means plus Ne charge. So what will be the net charge? Minus Ne, minus 12E plus 10E, which will give you minus 2E charge. So the charge on the body is minus 2E. So can I say this body has more number of electrons than protons? That's why the total charge is coming as negative. So there is excess of electrons. There is excess of electrons. So what is the difference? In neutral conditions, electrons are equal to protons. If the body has a positive charge, that means there is some deficiency of electrons. Or you can say there are more number of positive charge particles, protons. If any body is having negative charge, that means this body is having a more number of electrons having negative charge in comparison to the protons. Or you can say there is excess of electrons on that body. There is excess of electrons on that body. So the thing is clear. Now coming back to this friction or rubbing process, that what happens in friction and rubbing process, where whenever you rub or provide friction to any two bodies, there is transfer of charges takes place. There is some transfer of charge take place. Yeah, there is some transfer of charge takes place. Okay. Suppose these bodies are being rubbed against each other. So what will happen? A transfer of charges will take place, and you know only electrons or negative charges passes. So can I say if two electrons go from body B to body A, two electrons have transferred from body B to body A, can I say there is deficiency of two electrons in body B? Because two electrons have moved from body B to body A. So if there is deficiency of electrons in body B, how many deficiency? Two electrons. So the charge will be plus 2E. Because two protons are now more in number in comparison to electrons. Because initially the body B was neutral. You have taken two electrons away from the body B. So there is some deficiency of electrons that will give a positive charge, plus 2E, because now protons are dominating. Now what will happen in body A? Body A was initially neutral. It has got two excess electrons. It has got two excess electrons, which will give a charge of minus 2E. So what is the conclusion here in friction? That whenever friction process takes place or charging by rubbing takes place, charging by friction or charging by rubbing takes place, there is transfer of electrons from one body to another body. The body from which electrons are getting transferred will have a positive charge. The body on which electrons are transferred will have a negative charge. One thing you can observe there, that magnitude of charges are equal. Plus 2 and minus 2. Magnitude of charges are equal. So one conclusion is that during friction or rubbing, unlike means opposite, and equal means equal magnitude. Unlike and equal charges are produced. So in the process of friction or rubbing, what is happening? Unlike or equal charges are produced on both the bodies. The bodies on which charges are getting transferred, that means electrons are getting transferred, will get a negative charge or excess of electrons. And the body from which transfer of electrons is taking place is having positive charge or deficiency of electrons. So I think friction or rubbing is clear, that equal and unlike charges are getting produced in the process of friction or rubbing. So one body will get positively charged and one body will get negatively charged, but in equal amount. Okay, but in equal amount. Okay, done. Clear? Okay. Now let's see second method, which is charging by conduction. Now let's see second method, which is charging by conduction. So what do you mean by charging by conduction? Basically what we do, there is some conduction process which is known as transfer of electrons. So you can see in this diagram, there is some negative charge coming onto a body. So initially that body is neutral. So what is happening? A negative charge body is there. Negative charge body is there. It is getting touched to another body which is neutral. We are not rubbing actually. We are just touching this. We are just touching this body to a neutral body. This is neutral. So what happens? The charges of the transfer of charges will take place. The transfer of charges will take place up to when the charges on both the bodies become equal. When the charges on both the bodies become equal, suppose this body was having a charge of minus Ne. That means 10 electrons are in excess. So what happens when you touch this body with a neutral body? Equal number of charges will get transferred. So out of these 10 electrons, 5 electrons will get transferred into this neutral body. So if 5 electrons are getting transferred into this neutral body, then this body will have an excess of 5 electrons. Yes or no? So what will happen after this distribution? This body will get a charge minus 5e, and this body will also get a charge minus 5e. Why? because now out of the 10 electrons, 5 electrons have been taken by this neutral body. So the remaining electrons with this initial body is minus 5 electrons, that is 5 electrons, and the excess electrons gained by this neutral body is 5. So that means both will get equal charge. So suppose total charge on a body is Q, it can be positive, it can be negative, and that is neutral. So that is before conduction. That is before conduction. What will happen if you touch these bodies? Conduction is a process of touching the bodies. Yeah. When you touch these bodies, the total charge will get equally transferred. Suppose initially the body is having Q. This body is neutral, so total charge is 0. This plus this divided by 2. It will be Q by 2. So both these bodies will get Q by 2 and Q by 2 charge after conduction. The thing is that there can be a case when both the bodies are charged. When both the bodies are charged, suppose this is having a charge Q1, this is having a charge Q2. So when they are touched, then by the process of conduction, the total charge, that is Q1 plus Q2, will be divided equally. So what you have to do, just take the sum of charges and divide it by 2. So now both the bodies will get an equal charge of Q1 plus Q2 by 2. So what is happening? Conduction is a process of just touching the bodies, and in the process of conduction, equal charges are getting induced on both the bodies, or equal charges are produced on both the bodies. Okay. So what is happening? The body is getting negative. Now you can see clearly this negative charge was just touched with this neutral charge. This neutral body will also become negative. Yeah, equal charges. If it has minus Q, then both will have minus Q by 2 after conduction. So that is written. Electrons transfer to the object, making it in the same charge. So I already told you, from the negative charge body, electrons will get transferred. So that is the process of conduction. So I hope the process of conduction is also clear. Yeah. The friction was also a process of touching, but yeah, that is due to rubbing. And conduction is also a process of touching, in which you are just touching both the bodies, and both the bodies are getting equal charges on them. The thing is clear? Okay, done. So now moving on to the next process, which is induction. So induction is a process in which no physical contact is involved. You can see in the picture also, there is no actually physical contact between this negative charge and this body. Okay. So what happens in process of induction, we'll see with the diagram. Basically, we will observe this with a diagram. Suppose this is a negative charge body. What we do in induction, we make a negative charge or positively charged body near to a neutral body without any touching. Just make it near to this, or just place it near to the neutral body. So what is happening? Neutral body is having equal number of positive and negative charges. Yes or no? Neutral body is having an equal number of positive and negative charges. So what will happen? Due to this negatively charged bodies, positive charge will get attracted towards this surface. Yes or no? The surface which is near to the negatively charged body, positive charge will get attracted here, because unlike charges attract each other. So this negative charge will attract the positive charge of the neutral body. So if positive charges are here, on this opposite surface, there will be negative charges, because these negative charges are getting repelled by this negative charge body. So they will move away from its surface. So this is the condition. So what has happened? This surface has got positive charge, this surface has got negative charge. Okay. And what we do next? We have introduced the charge on this body. So there is some process which is known as earthing or grounding. So what we are seeing is earthing or grounding. This is very, very, very important. Earthing or grounding. What do you mean by earthing or grounding? Whenever we connect any body to the earth, this is the symbol for grounding. You are just connecting a body to the earth. Then that body is said to be earth or grounded. So earthing or grounding is the process in which you connect any body to the mother earth. Yeah, you connect any body to the mother earth. Okay, so what is happening? Suppose this body is having a negative charge. So earth is a conductor. You can imagine earth is a conductor, or earth is a body of infinite capacity. It has infinite capacity to take the electrons. From the body, or it has infinite capacity to transfer the electrons to the body. So it can do multiple tasks. Either it can take infinite number of electrons from the body, or it can give infinite number of electrons to the body. Both the processes the earth can do. Yes. So in this case, if this body is negatively charged and this body is grounded, then this complete negative charge or electrons will flow into the ground. So what will happen? This body will become neutral. This body will become neutral. Suppose I am taking a positively charged body. I am taking a positive charge body and I am earthing or grounding it. So what happens? Now electrons will flow from the earth. Electrons will flow from the earth to the body. Up to when? Up to when the total positive charge on the body becomes equal to total negative charge. And when the total positive charge on the body becomes equal to total negative charge, the body will become neutral. So what is the conclusion you are drawing? That whenever you connect any charged body to earth, either it can be positively charged or it can be negative charged. In both the cases, the body will become neutral. So that is the phenomena of earthing or grounding. If the body is negatively charged, the electrons will flow from the body into the ground. If the body is positively charged, electrons will flow from the ground or from the earth into the body. Because I already told you, only negative charges flows. Never positive charge flows during any bodies or between any body. So I think the process of earthing or grounding is clear. Whenever you connect any body to the ground, then that body will become neutral. Yeah, the case is that it can be negatively charged, it can be positively charged. But yeah, it will become neutral after earthing or grounding. Now coming back to induction. What is induction? We have already seen when you bring a negatively charged body close to this neutral body, then the positive charge will get attracted towards this negatively charged body and negative charge will get repelled. So what we do, we then place or earth this body. So whenever you earth this body, these negatively charged electrons or this negative charge which was present on this surface will get neutral by the earth. Yes or no? Earth will take these excess electrons. So what will happen? Only positive charges will remain on the body. Okay. So you can see the body will get positively charged. Done. What we have done, we started with a negative charge body. We make the negative charge body to move near a neutral body. And then due to the process of induction, we have produced the positive charge on the body. So what we have done, we have produced the opposite charge on the body. Without any physical contact. So that is known as induction. That you are just kind of inducing the charge on any body which is neutral without touching. So that is the process of induction, that without touching you transfer the charges from one body to another body. Okay, clear? So as now you can also refer this diagram. The negatively charged rod was brought near to this neutral body and you can see these red electrons. These red particles, electrons are getting transferred to the opposite face, which is away from the negatively charged rod. And the remaining charges here, which are near to the surface of negative charge, are protons, or you can say positive charges. Okay, so this becomes positive. So electrons move within the object, making the closest side oppositely charged. If this rod is negative, this will become positive. Either this case is also possible, that the body is positively charged. You are making this body coming near to a neutral body. So this positive charge will attract negative charge on this surface and positively charged will get repelled on this surface. So if you are making a positive body coming near to a neutral body, this will get negatively charged. And if you are making a negatively charged body coming near to a neutral body, it will get positively charged by the process of induction. So I hope we have seen all the three processes, that is friction or rubbing, conduction, as well as induction in detail. So in rubbing or conduction, there is some physical contact involved. Yeah. In rubbing or friction, equal and opposite charges are produced on the bodies. In conduction, the total charge gets equally divided between two bodies. And in induction, without any physical contact, we have introduced opposite charge on the body. So that is the process of induction. So I think the properties of charges, what is charge and what are the methods of charging, all are clear. Now see, this is electroscope. So electroscope is basically a device which is used to detect the nature of charges, or you can say to detect the presence of charges on any body. To detect the presence of charges on any body. Okay, so this is a device. This consists of a system like this. There is some metallic disc on the top. There is some insulation rod. The metal stem is there, and there is some gold leaf. Two gold leaves diverging. Yeah, two thin gold leaves diverging. Yes or no? There is some glass window from which you can make the observation, and this is the metal plate. Yeah, this is the metal stem, and this is the metal plate. Okay, so this is the system. Basically, if you see, we can also make this system in the home. You can take a bottle, put a cork on it, take a metal plate, hang the two thin gold leaves from this end. This is the setup of electroscope. So what happens when, suppose you are bringing a positively charged body to this rod. Yeah, when you are bringing a positively charged body near to the metal stem, this metallic disc. Yeah, what you do, you just place a positive charged body, touch the body with this metallic disc. So when you touch this body by conduction, the charge of this body will get transferred to the metal stem like this. Now this metal stem will get positively charged, and both the leaves will also get positively charged. So now if both the leaves are positively charged, we can say they will diverge. Yes or no? They will diverge. So as soon as you touch any body to an electroscope and you see the diversion, then you can confirm that there is some charge present, because there was no charge initially on the metal stem. When you touch the body, the charge from the body get transferred to the metal stem. So both the leaves will get equal charges. Both the leaves will get equal or like charges, and you know like charges will repel each other. So whenever there is repulsion observed in the leaves, we can confirm that there is some charge present on that body. Yeah, either also we can't confirm that the charge is positive or negative, but yeah, we can be assured that the charge is present. Now if we bring a negative charge body to the stem, what will happen? If we bring a negative charge body on the stem, so what will happen? Now negative charge will get transferred. Suppose I am bringing a negative charge body, so negative charge will get transferred on the stem. So both the leaves will get negative charge. Also in this case, there will be repulsion, because these are like charges, negative, negative. So you can see in both the cases, whether you are making a positive charge body touch the metallic disc, or you are making a negative charge body touch the metallic disc. In both the cases, there is repulsion observed between the leaves. So that repulsion or divergence will confirm the presence of charge on the body you are interested to study of. This thing is clear. So this is electroscope, which is an instrument which is used to detect the presence of charges on any body. I think this is clear. Thumbs up, guys. So we have done all the concepts of today. Yeah. Now we are going to see some questions. Yeah, some basic questions about the topic we have already studied. So it is asked, how many types of charges are gained by rubbing objects? So we have already discussed, while you are rubbing objects, in one body there is some deficiency of electrons which will get positive charge, and in another body there is some excess of electrons which will get negatively charged. Okay, but one thing also learned, that the magnitude of charges will be equal. Magnitude of charges will be equal. One will be positive, one will be negative. So how many types of charges are gained? Two types of. One is positive, one is negative. So answer should be 2. That there are 2 types of charges gained by rubbing objects. Clear? Okay, next. Now this is a very factual based question. That it is a convention. It is a convention that whenever a glass rod is rubbed with silk, you should remember this, whenever a glass rod is rubbed with a silk cloth by rubbing process, then the charge acquired by the glass rod is positive by convention, and the charge acquired by the silk cloth will be negative. Although both will be equal in magnitude, yeah, because this is a process of rubbing. We already seen in rubbing process, equal and unlike charges gets introduced on bodies. So in case of glass rod and silk, whenever you are touching or you are rubbing the glass rod with a silk cloth, it is a convention that glass rod will get positive charge and silk cloth will get negative charge. So what is being asked in the question, when it is rubbed with silk, what is the charge acquired by a glass rod? The glass rod will acquire a charge of positive by convention. This is basically a convention. Clear? Thumbs up. Okay, guys. Now next question. When two bodies are rubbed against each other, they acquire. Yeah, very simple question now. We are a pro in rubbing or friction. So you all know, whenever two bodies are rubbed against each other, they will get equal and unlike charges. They will get equal and unlike. That means one will get positive charge, one will get negative charge, but in the same magnitude. So the equal and unlike charges will get produced. Okay. Yeah. Now next question. The process of transfer of charges from a charged object to the earth. So whenever you are transferring any charge from charged object to earth, that process is known as earthing or grounding. We have already seen that process is known as earthing or grounding. Now I think this is clear. We have done all the possible questions on this topic. So we have seen everything in detail. We have seen charges, we have seen what is charge, we have seen properties of charges, additivity, quantization, conservation, like charges repel, unlike charges attract. Then we move on to the methods of charging, that is induction, conduction, and friction or rubbing. Induction is a no physical contact process, while conduction and rubbing or friction is a physical contact process. And we have already seen there is an instrument which is used to detect the presence of charge on any body, which is given by electroscope and which is known as electroscope. So I think everything is clear what we have done in today's lecture. Okay. So thank you so much. Yeah. So in spite of this, if you find any kind of doubt, you can directly reach on to the doubt forum on our askIITians website and post your doubts there, and they will get solved by our experts. Okay. So thank you so much, students. Stay safe and enjoy.